Okay, well, good. It looks like we're connected. I appreciate it. Thank you so much. Well, good morning, everybody. I appreciate the opportunity to be here before you today. Obviously, yeah, as was said earlier, it's just a nightmare situation. What's happening to our friends in Ukraine, and I'm, uh, you know, truly evil situation. So I'm very sorry I'm sorry we're gathering under these horrible circumstances, but obviously I stand with Ukraine, and I hope all of you do as well. Um, I'm glad to be here. I am super glad to be here. It's such a weird world we're living in. 2022 is absolutely crazy. If you had told me 12 years ago I'd be signing in to do presentations from another country to support another country that's being war torn in the middle of a global pandemic, it's just, yeah, it's all too gloomy to think about, isn't it? So we're going to focus on. And by the way, I have a bit of a cold. You can probably hear it in my voice. It's getting worse, it seems, by the minute. But today we're going to focus on building apps for production, where today, as often as not, production is Kubernetes. And so we're going to look at the latest and greatest in the wonderful and wild world of Spring. And we're going to, wherever we can, highlight some of the latest and greatest in the Spring ecosystem, including some forward-looking stuff. So let's talk about that. Before we get into this, right, I'm going to build a new piece of software. Obviously, I'm going to go to my second favorite place on the internet, start.spring.io. My first favorite place on the internet, of course, is production. I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather's amazing. It's the happiest place on earth. It's better than Disneyland. But if you can't get to production, or if you haven't been to production, then you can start your journey here at start.spring.io. And what we're going to do is we're going to build a new application. And we're going to use Spring Boot 2.7, which is the current latest GA version of Spring Boot. And we're going to use Java 17. So let's talk about that. Spring Boot 3 is coming later this year. The plan is for, by the end of the year, to have Spring Framework 6 and Spring Boot 3. These are huge new revisions, huge new baseline revisions of the Spring Framework. And those don't come along very often. We've been using Spring Framework 5, with lots of updates, right? 5.6 or something like that at this point. But we've been using Spring Framework 5 since 2017, right? In September. Actually, this is 10 years. 10 years since 5 years since we released, 10 years. 5 years since we released Spring Framework 5. That came out in September at some time. So this month will be 5 years. And by the time Spring Framework 6 comes later this year, it'll be more than 5 years. And so Spring Framework 6 is a brand new baseline. It gives us a chance to assume new baseline revisions. And so there's some good news and some other news. It's not bad, I guess. It's just tedious. It's annoying, right? So the good news is we're assuming a Java 17 baseline, right? So in order to use Spring Framework 6, you have to use Java 17. This is a good thing overall, right? Because obviously Spring Framework 5 came out 5 years ago, and with it came a baseline of Java 8, which was not that aggressive at the time. But consider where we are right now. Spring Framework 6, 5 years later, we're on Java 17. Actually, by the time Spring Framework 6 comes out, we'll already have Java 19, right? So really, 17 is already 2 versions behind. Remember, there's a new version of Java every 6 months, and that means that you can get the latest and greatest bits every 6 months. There's a new long-term supported version of Java every 2 years. So already we'll be halfway to the next long-term supported version, which is Java 21. So there's going to be lots of stuff in Java that's already available. That's already available. That we don't assume it needs to be there, right? So in your Spring Boot application, you can take advantage of it. We'll support it, but it's not required. So Java 17 is the new baseline. This may seem aggressive relative to Java 8, but it's not, right? It's really not. We're already 2 versions behind. And looking forward, considering the 5-year window that we've had for the last release, I cannot see the future. I cannot speak with certainty about the future. Of course, nobody can. But considering the time it took to get from Spring Framework 5 to 6, if we have another 5-year window and there's 2 releases every year, that'll be 10 more versions. So Java 29, right? We could be at Java 29 or Java 30 by the time Spring Framework 7 comes out. So by then, we'll still be able to support Java 17. That's not very aggressive at all. That's a very conservative, easy baseline, right? For 5 years, half a decade, 1/20th of a century, right? It's a good long time. So we hope people will move to Java 17. It's awesome. I can't imagine using anything but Java 17 or 18 or 19 or 20 or whatever. Anything less is a terrible idea. Remember, Java 17 is technically superior in every way. It's faster, more secure, more performant, more syntax rich, more operations friendly, more memory efficient. It's technically superior in every way. It's also morally superior. You won't like the look of sadness and despair in your children's eyes when they see that you're using Java 8 in production. Don't do it. Be the change you want to see in the world. And, judging purely by the version number alone, I think we can agree Java 17 is more than twice as good as Java 8. And so I think that's a pretty compelling case as well. I'm all about staying on Java 17 or upwards. Java 17 is the right thing to do in 2022, my friends. So make it happen. That's going to be one baseline change. The next is that we're going to be using Jakarta EE. Okay, so all the libraries that we have in the various portfolio projects that support imperative blocking synchronous I/O, such as those that come from the Jakarta EE specs, there's a bit of a problem here, right? There's a bit of a change here. Jakarta EE, for those of you who haven't been paying much attention, it's the new name and new management of what we used to think of as Java EE. Now open source, they live at the Eclipse Foundation, but as part of the deal that allowed the Eclipse Foundation to manage these open source projects and to evolve them, there was a stipulation. And again, this is legal, this is political, this is lawyers, not software engineers, right? This is not something that anybody who works on the tech had any control on. But because of the precarious legal situation in which Java EE used to be, in order to get it open sourced, they had to agree that if any new changes are made to the types that were in Javax, JAVAX dot asterisk, if anything changes in those types, then they must live in a new package, right? So if you change a method, if you add a method, if you delete a method, if you add a type, anything like that, that has to be in a new package. It cannot be Javax dot asterisk. And what that meant effectively was that every program that's ever been written in the last 25 years or whatever is now broken, right? Backwards incompatibly. But the good news is it's an easy fix, right? The hard stuff we've already done for you. All the infrastructure, all the supporting libraries, things like Hibernate and Tomcat and Jetty and all that, they all support the new namespace. So to the extent that they are required to update their internal code, that's already been done, and that's being packaged in Spring Framework 6. You will see some, but keep in mind, it's just a find and replace, right? And I expect there will be tools that will be available to make this migration as painless as possible, right? Automatic tools for IntelliJ, Visual Studio Code, Eclipse and the Spring Tool Suite in particular, etc. I don't know the state of all of them, but I know good things are coming. Overall, this is a good thing. And to their endless credit, the Eclipse Foundation and the Jakarta EE people have done a great job technically of making it so that it costs nothing except for a find and replace to update. So they released one version with a new license with the old types, nothing new, nothing changed. And they released another version with the new packages, but again, basically the same. So there's no new features for like the last 5 years of Java EE / Jakarta EE, but there is now a smooth, backwards compatible ramp that you can take to move to the new version without breaking code. And that's a big deal, right? Without breaking the semantics of it. Obviously, it's going to break the packages. And that's easy enough to fix with a quick sed or find and replace or whatever. So that's the new baseline. That's new Spring Framework 6 and Spring Boot 3. It's a wonderful opportunity because with that new support comes built-in support for GraalVM native images. Now, today we're going to look at some of that in terms of Spring Boot 2.x and Spring Native. Okay, Spring Native is a separate project that you can use today for Spring Framework 5, and it's it works well enough for Spring Framework 5. It's a suitable solution for Spring Framework 5. It is not technically compatible with Spring Framework 6, but conceptually it's compatible, right? The work that we're doing in Spring Framework 6 is built into the Spring Framework itself. It's not a separate project. It doesn't have to act on Spring from without Spring, right? It can work inside of the engine itself. So it's a different implementation, but conceptually, if you learn Spring Native today, you'll have the right tools and you'll know what to look for in Spring Framework 6 and Spring Boot 3. Okay, so we're going to build a new application called Customers. We're going to use the reactive web and the H2 in-memory database and R2DBC and Lombok and the Spring Boot actuator and Spring Native. Okay, so I'm using a lot of reactive APIs here. R2DBC is a reactive database access library. I've got the reactive web support built on Netty. And these types make it so that I can write code that takes advantage of reactive programming, which gives me 3 huge benefits. The first is that it's now easier to write code in a safe, consistent way because I have a single, sane, consistent programming model, a threading model. The second is that I have a single abstraction, and therefore I can compose data from different sources, no matter what the cadence of that data, the speed, the size, the frequency, etc. And then 3, I have a single place in which to address reliability concerns, things like back pressure and retries and timeouts and so on. I have a single abstraction that I can use to make my code more robust. So better threading, robustness, and ease of composition. These 3 big benefits are huge. Obviously, one of the things that's implied in that better threading bullet point is that you have a programming model that makes it efficient to write code that handles more demand, more load. And this situation is as good as it's going to get right now in the reactive world. But of course, when Project Loom comes, that will get even better, right? It's already a lot better right now than using synchronous blocking APIs like the servlet specification and JDBC. So it's a much better situation than that. But with Loom, I think there's even more opportunities for win. So I can't wait to see what that means in helping that first bullet point be even more valuable and more useful for people. Let's hit generate and download UAO customers.zip. Okay, there's my application. Get some cool air in here. Good. So it's loading. Okay. So what I want to do is I want to build an application that writes data to the database. I'm going to create an entity that manages that. So customer, integer, ID, string name. Obviously, just a record. Java records are awesome. Look, no Lombok, right? This is awesome. So now I have a thing I can use to save to the database. I want to create a repository. Extends the reactive code repository support there. Primary key type integer. And now I want to save this to the database. I'm going to create an initializer bean, and it's just going to listen for the application ready event. Okay, so when the application starts up, public void ready, and I'm going to need a pointer to actually I'll make this a bean I'll just create a little inline bean. It doesn't need to be a whole standalone object. So application listener, application ready event, ready, and I'm going to depend upon my repository there, and I'll say return new application listener, and of course this turns into a nice little opportunity for us to initialize some data. So we'll go write some names of people on the Spring team, obviously. Jürgen, Oleg, Dr. Sire, Stefan. No particular order here, obviously. Olga, Violetta, Artura, Yushin. Okay, so we have some people on the Spring team there. Names.map, name, new customer. Passing in null for this. I'm going to save each record using the repository, thusly. Okay, so there I'm saving the data. And when I'm done saving it, I'll just call subscribe. And then I'll make this a Lambda, of course. Okay, so there we go. Now I need some schema, don't I, right? So I'm going to create a little schema file here. schema.sql, create table, customer, ID, serial, primary key, name, varchar 255, not null. Okay, whoops. So now let's run this and see what we get. Okay, good. So it's up and running. Maybe I can just print out the results, huh? So system out, print line, restart. In the meantime, I want an HTTP controller that I can use to get access to that data. Response, body, class, customer, HTTP controller, private final, customer, repository, and we'll inject that into the constructor at get mapping customers publisher of customer get find all. Okay, good. So we can restart this. Goody. So there it is. There's our application. Localhost, customers, voila. Okay. There's our data. It worked. Of course it worked. It was a demo. It was always going to work. That's not really what I wanted to talk to you about. Anybody can build an HTTP API and manage access to a database. That's not interesting here. What I care about is how can I get this application to production. And to support that, I have on the class path here a Spring Boot actuator module, Spring Boot starter actuator. This gives me managed endpoints. So things like management exposure equals everything. I'm going to enable the probes for Kubernetes. So I have a readiness and liveness probes. And I'm going to show the details for the health endpoint. Okay, now these are not suitable for your production application, but for our demo, we're going to just show everything so we can kind of see what's happening. So when I go to actuator, I get a number of HTTP endpoints. Things like the beans, which shows me all the different Spring beans in the application context. The caches, which shows me all the different caches in the application context, of which I have none. The info endpoint, which you can use to customize. You can put arbitrary data there. You can say info env endpoint equals true. And then you can say info.message equals I stand with Ukraine, right, like this. And if I restart, info, env, info env, all right. There you go. So I can create a custom message that appears. You can put whatever you want here. You can put identifying information about the name of the build itself. So for example, I can go here and go to the parent and I get the git commit ID plugin. That's this thing down here. It's already pre-configured. You just have to opt into it by going to your build plugins. Paste that. I don't need the version. Of course, that's specified by the parent. And then if I go to the command line here, git init, git add, git add.mvn, git add.gitignore, git commit -a, -m, YOLO. Okay, so now I've got a Git repository. Let's do a quick build. Beg your pardon. Okay, so I built it. Now, if you go to the command line, cd target, find iname git.properties, right? We can see there's this file that was written that captures the current state of the Git repository, the Git commit ID, the username, the email, the version, the author name, the ID, all this stuff. Now, if I restart my application with that on the class path, it's in the jar, right? It's been compiled and it's on the class path. Go back here and I have all this extra information that identifies the version of the code that's running in production, right? This is very good for observability. We want this, right? So this kind of helps you understand what is running in production. You can then trace it back to, Josh made a mistake, again. So please fix it, Josh. Okay, so there's the env endpoint, which gives you your environment variables. Loggers shows you all the different loggers and their log levels. You can post to that endpoint to change the log levels dynamically from, like, for example, info to debug for certain packages, maybe, so you can debug in production. You've got thread dump and heap dump, which gives you, threads and heap dumps. You got metrics, which shows you keys and values, statistics about the application. This is in turn powered by Micrometer. Micrometer is a vendor-neutral application metrics facade, and it has lots of great support for built-in time series databases, including AppOptics, Azure Monitor, Netflix, CloudDog, Google Cloud Stackdriver, StatsD, and of course VMware's Wavefront, and Prometheus, which is super common in the Kubernetes world. So you can you can read the metrics here, but it's much more useful if you use the micrometer binding of your choice and then publish it to a time series database like Prometheus, so you can view everything from all the services in one single pane of glass. Very important, right? We've got mappings, which shows you all the different HTTP endpoints and the components that provide the behavior for those endpoints. So, for example, when you go to actuator heap dump, this class and this method provides the response, etc. So, okay, all this stuff gives us interesting information about the application. To me, one of the most important is the health endpoint. The health endpoint gives me a listing of all the different subsystems in the application that, if they were to fail, would mean that the service itself is sick, right? And so you have the status of the database, the disk, hard disk, the liveness and readiness probes are there as well. So if any subsystem, if the disk space health indicator fails, then the total status is also going to fail, right? Instead of saying up, it'll say down, and you'll get a 500 error instead of a 200 error. And so this is very useful for understanding the state of the service. This is a general purpose health indicator, and you can use that with any cloud technology. But if you're using Kubernetes, it expects two things in particular. It expects a readiness probe, which tells it whether the service is ready to be put in production, and it expects a liveness probe, which tells it whether the service should stay in production. These configuration values, they're basically specializations of the health indicator that we already have. So we provide that for you here out of the box, and you can just point your pod or your deployment to those health indicators as required. So we have these health indicators. We have liveness and readiness probes. What happens if something goes wrong? What happens if your application becomes sick? Well, the status will go from up to down. You'll get a 500 error. Kubernetes will see that something has gone wrong, and then it'll seek to kill the pod or the deployment, and then reschedule it, right, to create a new instance of it. So what happens to the in-flight transactions, the work that you're doing already in that JVM? Well, you want to make sure that it doesn't just drop everything on the floor, right? So we have graceful shutdown, right? So shut down. Instead of saying immediate, which is the default, we want to use graceful. So graceful is, it's going to shut down the JVM slowly. It's going to shut down the JVM slowly, and then it'll give you time to finish what you're doing. It'll stop accepting new requests. Okay, so you can say, I want 30 seconds. You have to specify the equivalent value in your Kubernetes pod, grace period property, or your deployment, same thing. And so here I'm saying I have 30 seconds between when I get a sig term, the signal from the operating system, and when I get like sig kill. So I'll get 30 seconds to finish whatever I'm doing. And if I'm still running, if I'm still doing something, then it'll kill -9 my process, basically, right? But if I shut down everything before that, then great, it'll just shut down as per normal. Normally, you get the sig term and then sig kill immediately. There's no time in between. So here we're getting 30 seconds between the signal and then the actual killing of the pod, right? This is great because now my in-flight work, I can finish it off, or I can reject it or whatever. Even better, Spring Boot will stop accepting new requests during this period. So if you have a web server or something, it'll stop accepting new incoming requests, so that you're not taking on more work as you're trying to finish the existing work. You can set this value to be whatever you want, but make sure you synchronize it with the Kubernetes value as appropriately. Okay, so now you've got graceful shutdown. This is Kubernetes specific, right? So is this, basically, in this case. Maybe the probes configuration right here is Kubernetes specific. So you can actually have specific configuration. You can say, I want to activate on a cloud platform. I want to activate on Kubernetes. So everything after the --# is unique to that environment, right? I can also activate on a profile, right? I can say on profile equals cloud or whatever, whatever profile you want, a Spring profile. But if you just want to behave differently based on when you're in Kubernetes or not, you can do that. And so I can create a new message here. Maybe it's Kubernetes, so I stand with Ukraine.yaml. So that's the Kubernetes version, and that's the regular version. So we can actually, right now I'm developing on my local machine. Obviously, this is not Kubernetes, but if I wanted to like easily pretend I'm in Kubernetes, I can set the Spring main cloud platform as a property. So let's do that here. We'll edit the configuration. Okay. And I'll add some program arguments. -- Spring main cloud platform equals Kubernetes. Hit apply. We'll restart. Okay. So now let me go back to info. And there's the YAML version, right? I stand with Ukraine.yaml. If I go here again and then remove this, okay, hit apply. I get regular I stand with Ukraine, right? So you can easily see why that's useful. You can also do this for Java beans. Maybe you have a bean that is only in Kubernetes for some reason, right? I don't know. Maybe you have a different implementation or something. So class Kubernetes greeting controller, something like this. Hello on Kate's string hello, right? I can do that, and I can have at conditional on cloud platform Kubernetes. So this bean will only be created if we're in a Kubernetes context, right? Now, let's say I go back here and I add that property. I'm going to pretend I'm running in Kubernetes again. Go to program arguments. Go here, -- Spring main cloud platform equals Kubernetes. Hit OK. Now, if I do that, the application is going to need some configuration. Obviously, this configuration is right here. But what if I have secrets or environment variables or things like that? Well, in Kubernetes, you take configuration from something else in the world. It doesn't matter what. And in order to feed it to your application, you turn it into something called a config map or a secret. If you want to read that configuration, you have to expose it to your application in one of two ways, maybe three if you're really specific. The one way is to take that config map or that secret and create an environment out of it, right? You can create environment variables from the entries in the secret, which is a dictionary of keys and values. The keys become the environment variables. The values become the value of those environment variables. That just works. You don't have to do anything special. So if you're using Spring Boot and you have an environment variable in your environment, you can do export server _ port equals 8020, and that'll override the default server.port property in your properties file, right? So if you take an environment variable from your secret, from your environment, and you override, then this will just work just like you think, right? If you want to use a config map as a volume, you can mount a config map as a volume, which is a directory structure where you have keys and values. So I go here, let's say desktop, and I'm going to create a new directory called config. And in the config directory, I'm going to create a new file called 8090. I'm going to echo that to server.port. So I have a file called server.port, right? I'm in a directory called config. You can call the directory whatever you want, right? I'm going to just take that value there. Okay. I want to import that configuration. When you mount a secret or a config map as a volume, you get a directory structure like that. We call that a config tree. And Spring Boot has great support for importing configuration from various places. There's even pluggable. It's even a schema. It's a pluggable schema resolver, so you can load configuration from, for example, the Spring Cloud config server, from HashiCorp Vault, from Zookeeper and Console and whatever. But some of the schema resolvers that we have built into Spring Boot itself, without loading any external projects, are for class path and file-based resolution, for optional files that may or may not be there, and for config trees. So I can say, hey, I want to load the config from this config directory. Okay, so I'm importing configuration, but only if I'm inside of Kubernetes, right? Let's just pretend that's where Kubernetes mounted my config map. Okay, so if that works, then the port of the application should start up in port 8090 instead of the default of 8080. Do I still have that property? Yeah, it still says Spring main cloud platform equals Kubernetes. Let's go ahead and restart. Okay. On port 8090, right? So where is that port? 8090. There it is, right there, right? So we have our application on a Kubernetes specific port. If we drop this property, well, you can guess what's going to happen. It's not going to import the configuration. The configuration won't be overridden, and it'll go back to the default, which is 8080. Okay, so now we have an application. I want to take this to production. I've addressed observability a little bit. We've looked at ways to make it more aware and more dynamic based on the environment it's in, to embrace and work with a Kubernetes context. Now, I want to package this up for production. And there's two parts to that. One is, do I just ship the jar? I could do that. That's no problem, right? Java's fine. You can just do, you can use build packs. We have a thing called build packs. So buildpacks.io. This is a way to take an artifact and turn it into a container that can run on any cloud. So you can use there's builders for all sorts of languages. This is a Cloud Native Computing Foundation spec. And the idea is that you take our application artifacts in and you get out a container. You can use the pack CLI, or you can use our built-in support in Spring Boot. So you can say Maven Spring Boot build-image. And you could do that, but I don't want to do that right now. It takes several minutes, for a complicated enough build. What I really want to focus on is I want this application to be a GraalVM native image first, right? And so rather than shipping a jar, I want to ship a GraalVM native image. GraalVM is a native image compiler. It has a native image compiler that is it's kind of like the just-in-time compiler, except that it compiles everything into native code. The important thing to remember here is that GraalVM hates your code with a deep, fiery passion, unrivaled by almost anything. It hates it with a passion. It wants your code to be C++, right? It hates runtimes. It hates reflection. It hates serialization. It hates loading things from jars. It hates proxies. It hates basically all the dynamic things that make Java so powerful, and separate it from the likes of C, right, and C++. It hates all of that. You can tell it not to get so upset about that stuff by providing configuration files. Those configuration files can be quite verbose if you have to write them yourself. So we have a project called Spring Native. And Spring Native is on the class path here. You saw that earlier when we added it back at start.spring.io. It added the Spring AOT Maven plugin, the ahead of time compiler Maven plugin, and the Spring Native library for the runtime. These types teach GraalVM about all the dynamic things that a typical Java application will use, and it provides the hints, config files that tell it what to do, so that for the most part, your application should just work. Where things become a little tedious is if you have things that you're doing in your custom code beyond just registering beans in the Spring context that we know about. In which case you can do hints. So you can say type hint, org Spring Framework native X hint, right? And you can say type is equal to whatever. Maybe I have some custom type that needs to do reflection. Whatever. It's just choose. Obviously, I'm not gonna. That's not. You don't need to do this for this one. But and you can say access equals, and then you want you want to access reflectively all the public classes or something, right? So you can register hints using annotations. There's even a programmatic way to register hints. You can create like auto configuration that programmatically registers hints that gets fed into the GraalVM compiler. So that's already been done. I don't need to do anything for ours because this is a stock standard vanilla Spring Boot app. There's nothing special about this in terms of minus P is native, right? Okay, so and then I'm going to say clean package. So this will take, I don't know, a minute and a half, whatever. It's going to do a analysis of not just our code. Remember, I've only written like nothing, right? It's 70 lines of code, but really, I mean, come on, like this I don't need, and I don't need this, right? So if you got rid of all that, that's 47 to 27, so that's 20 lines right there. So really the whole thing, including public static void main and my ridiculous controller, which is just a demo, is 30 lines of code. There's nothing special about this. This is a trivial application. So it's going to analyze that 30 lines of code, but it's also going to analyze all the types that code in turn uses, right? So if my code calls some other code and that code calls some other code, there's an implicit sort of cascade of reachability, right? One thing reaches another, and that whole graph gets compiled for every type on the class path and every type in the JRE every time you compile. I hope in the future they can like learn to cache some of this. Like I can do the analysis once, and then as long as my class path is stable, why do I need to do the analysis again, right? That would be nice. So there you go. It took a minute. The result of this is that you get a binary that is self-contained. It's 78 megs. That includes the runtime. It includes my embedded database, my SQL database, my embedded web server. It includes all the Spring Boot actuator stuff. It includes my business logic, right? So all of that is in that 78 megs. That's including the JRE, right? Or at least the parts of the JRE that my code is using, which is nice. It's also Mac OS specific, right? So, it's port 8080 is already in use. All right. Stop this. Okay. There we go. So there's my Netty application. It started up in 57 milliseconds, 57 thousandths of a second, include to do everything, right? Amazingly, this is even faster on Linux. I don't know why. I think the compiler for macOS is kind of like less efficient. It works. Obviously, you can see it works just fine, and it's still fast enough. But I've gotten more phenomenal results. I can actually use the build packs about which I spoke a minute ago. I can use build packs to create a native image in the build pack. So if I ran that same command that I showed you earlier, maven spring-boot build-image, it would create a native binary for Linux in a Linux container. It would compile that code in the Docker image, not on my Mac, and then it would store the results of that build in the container itself. So when I start up that container, somehow running that Docker image on a virtual machine, on Docker desktop, on my Mac, is still faster than running the native image directly on Mac, compiled for Mac, right? I don't know how, it's witchcraft and sorcery, but it is amazing. So check out the native image support. And remember, as easy as this was for Spring Framework 5, it'll get even more amazing, right, in Spring Framework 6. Okay, so now I have a server. Let's build a client, okay? So we'll go here, start.spring.io. We're gonna build an edge service. Edge services are great ways to provide the data in your application and expose it to the outside world, okay? So we're gonna look at a few things here that might be useful. We'll hit generate. And the reason you wanna do this is because you might have an application that, you might have an application that has multiple services and your client wants to consume that data, your iPhone device, your Android device, etc. That is very common, right? It's very common to want to be able to get all that data, but you don't want to make your Android device, which might belong to somebody who's roaming in some other country they have their network plan gives them inferior network coverage. So when they travel across the country or out of the country, it degrades because it's cheaper that way for the telco. I've been that person, right? I've been out there, in America, I have 5G, but when I go to some other country, almost any other country, I get downgraded to 3G, right? You don't want to make some poor person who's got 1% battery on a slow Android device, who's that is running a full JVM in there. You don't want to make that poor person have to call 5 different network services from the Android code, right? It's going to waste bandwidth. It'll take forever. The service orchestration composition logic is now duplicated in each client. So the iPhone client, the Android client, they all have to figure out how to concurrently call all these different services and compose the data into one to create the right payload, the right view of the data. This is something that should be done at the edge, okay? And so at the edge, you want to make your data available to the client for lots of different reasons, right? Just think of performance and security and routing and all this stuff. One way to do that would be to use Spring Cloud Gateway, right? Spring Cloud Gateway is an API gateway. So I can say I want to build a route locator builder. Return rlb.routes.build. I'm going to build route rs path proxy URI HTTP localhost 8080. So I want to proxy requests to this service, right? Server port 9999. When somebody comes to the service and goes to /proxy, it'll forward on to localhost 8080. But remember, I want to send it to /customers. Really, that's where the endpoint that I want is, isn't it? So I need to change the path of the request. The request, when it comes in, will have a path of proxy. I'm going to use a filter here to change the path to be customers. Okay. Filters are where the real power of Spring Cloud Gateway is. You can do amazing things with filters. You can add request headers or response headers, right? I want to add core support, for example. Access, allow origin Okay. Maybe I want to do that. Maybe I want to do a retry. If it fails, I can try again. Maybe I want to do a rate limiter, right? I can do rate limiting if I want to use Redis, for example, to store the quota, the number of requests across all your service instances. I can do that. I mean, you have all sorts of different filters here. And if you don't find one that you want, then just create your own. Easy as pie, right? Look at that. So you can act on the requests before they get forwarded downstream. Okay, so that's a useful thing to do. Let's try that. So here I've just added CORS headers to my microservice. I didn't have to change this downstream service. So curl HTTP localhost 9999/proxy, and there's the data. Oh, I've got this. I'm using macOS M1, and Netty hates that, so I have to do this to get everything to work. Netty all reload. Okay, rerun. Good. So take 2. There you go. So now I get the same data, and I don't have that nasty, stack trace there. Okay, so there's my data. If I go -v, you can see. Oh, no. Sorry about that. -v. You can see I've got access control out origin equals asterisk, right? I've added that header as well. So proxies, gateways, that kind of stuff, great idea. Another thing you might do to make it easier for people to consume your data is to use GraphQL. Now, GraphQL is great because let me show you an example here. API.spacex.land. Oh, hey. Oh, that's interesting. They moved API.spacex.land, so they're using Heroku for this. You heard that Heroku just disabled their free tier, right? And so all these apps have like a couple of months or less to move their apps away from the free tier. I wonder if this is related to that. Oh, that's so funny. Huh. I'm going to take a screenshot. Okay. Anyway, their GraphQL endpoint used to be right there, right? You could go there and get the GraphQL data. But GraphQL is great because it gives you schema. So I'm going to create a schema here. So I'll say new directory GraphQL, new file called schema.graphqls. Okay. And then you describe the types of your data set, right? So I'm going to create an idea called a type called customer that'll have an ID and a name that's a type string. And I want to make this data available to the client. Well, the client, by convention, looks in the query type for the endpoints that it can read from, right? All the fields that it can read from. Fields are like endpoints, right? They're the thing that you can read from or use to invoke a change, to mutate state on the server side. So I'm going to get all the customers. This endpoint is called customers, and it's not going to return. It's not going to return. Gee whiz! It's not going to return a single customer. It's going to return multiple customers, right? So I'll now implement the controller that satisfies that endpoint. So at controller class CRM HTTP controller. Okay, and I'll say schema mapping. Type name equals query and field name equals customers, and I'll return a stream of customers. Well, of course, I have to create a DTO or a POJO or whatever for the data that's coming from the other server. So here we go. Name, customers, return, and I need to get that data, don't I? So I'm going to use a reactive non-blocking HTTP client, and I'll inject that into the constructor. And I'll say this.http.get.uri HTTP localhost 8080/customers. And then as the data comes back, I'm going to provide customer.class, right? So there's that. I'm going to take the JSON and turn it into a class of type customer, okay? So this is my GraphQL controller. Let's go ahead and restart it. Oh, I need to define the web client, don't I? It's going to fail. Oops, I forgot about that. Web client.builder. It even just told me that. That's nice. It gave me a clear error saying, hey, you need to do this. Good. Restart. Okay. So localhost graph. Oh, and I want to interrogate this. I want a schema. I want to place a console that I can use to get the data. So I'll say graphical enabled equals true. That's actually the same thing that they used to run at api.spacex.land, but that's gone now. It looks like graphical. Well, that's a bummer. Not found. Oh, 99.99 graphical. Yeah, sorry. Okay, there we go. There's the console, and I want to get the data. Let's close all this. Wow, that's cool. Okay, so I want to get the data. I can use a query. I want to get the customer data. Notice that if I just leave it like that, it gives me an error, right? It's saying you have to select what subfields you want. Okay, what subfields are there? There's ID and name. Okay, so I want the ID. Great. And I get that data back. I get the customers with just the IDs. Well, what if I want the name as well? Okay, no big deal. Ask for that as well. So I'm getting only what I asked for, right? I don't get all the data. And this is really nice about GraphQL is that you can ask for as much of or as little of the data as you want. So if you want to do a search endpoint, you can return the full object if you want. But if the client doesn't need all of it, if you just want to show the details or the overview of the results, fine. You don't have to pay for all the little nested calls and network calls that have to get loaded for you to make that network call, right? But what if I wanted more data? Well, what if let's imagine I had some other microservice, another microservice on another port that provided profile data, okay? Well, here I can say profile, integer ID, okay? I'm just gonna imagine, we're just gonna pretend, we're gonna say that there's some other microservice that I've already written, which I haven't, I'm just gonna pretend, and it's gonna be called the profile service. It's gonna return a profile. Well, that profile belongs to the aggregate of the customer, even though the implementation is a different microservice, maybe even using a different technology. From the GraphQL perspective, it makes sense that the customer owns the profile, right? So I can actually add this as a part of the schema. And here, now you can see my schema is diverging from my actual object structure, right? The arrangement of the objects in my code and in their representation in each of these microservices is now different from the perspective that the client gets about that data. It doesn't need to know that this is coming from a separate service and that it's not actually part of the same database or schema or whatever as the customer data. So how do I resolve profiles for a customer? Well, I can create another endpoint here. At schema mapping, type name is equal to customer, and the field is equal to profile, okay? So now, when somebody asks for a profile, I get a reference to the root of the aggregate, a customer, and I can, let's say I'm doing a network call and I can look up the profile remotely, right? Here, I'm just creating a little in-memory version of it so you can kind of see it work. But imagine I've got a reference to the aggregate. I now call the profile service, get me profile by customer ID or something like that, right? Okay, so now I can refresh this. Let me close that window. They're doing construction downstairs. Sorry about that. Okay, so hit go. So there's the customers, the IDs, the names. But now I also want the profile. And again, it has subfields, so I need to specify which ones I want. So now I ask for the profiles and I get the profiles. If I don't say profile, then this expensive network call never gets made. There's no call to another service that gets made here, right? So I don't have to pay the cost of n+1. I get 10 customers, and then I make 10 calls to the profile service, right? Only if I ask for it do I get it, right? And that's very, very nice about GraphQL is I can get as much or as little as I want. But still, this is a little inefficient, isn't it? It's an n+1. If you have a network endpoint that gives you all of the profiles for a given customer, like you give it a bunch of IDs and it gives you a bunch of profiles back, and you want to use that, or if you have some database schema query that you can use or something where you can do it in one fell swoop, that's even more ideal, right? So here, you can actually use something called batch mapping, okay? So here I'm going to say the type name is equal to customer and the field is equal to profile. But instead of returning a single result, I'm going to return a map, right? A map given a list of customers. My job is to return a map of customers and profiles. So let's say map, var map equals new hash map. And I want this to be customer profile. Okay. So for var c customers, map.put c.id, I just want c, and then new profile c.id. There we go. So now I'm just returning, this is obviously, I'm just making this up, right? I'm just doing it in memory here, but imagine you're making a network call. I no longer need this n+1 version. Now I'm going to make 2 network calls, right? So I'll say system out, get all profiles. Okay. And then system out, get all customers. Okay. So now I hit refresh. I get the same data as I did before, but now I'm only making 2 calls instead of 11, right? This makes it more efficient. Now, obviously, there's some opportunities for improvement here. First of all, Spring can derive the name of the field from the name of the method. So you can drop field equals everywhere, right? As long as the method is the same. Why? There's no need to specify that. Second of all, if you're getting data from a type called query, that's a convention. It's a well-known convention. So well-known, in fact, that there's an abbreviated, shortcut annotation called query mapping. It's kind of like the relationship between request mapping and get mapping, right? Here, we're saying there's a specific annotation that is basically itself schema mapping with the query being defaulted to query, right? It's just plugging in the same thing. So for this particular case, for higher level things, there's query mapping. There's 2 other types that have a relationship like this. One is called the mutation type, which is where you keep all the things that change the state of the server. And the third one is where you have a subscription type, which is where you keep all the things that return ongoing streams of data, like stock tickers or sensor data or whatever. So you can create, you can use @subscription mapping or @mutation mapping for fields that live in those 3 or those 2 other types respectively. Okay, so now this is the same exact thing as before. We've looked at how to create a very efficient GraphQL endpoint. Okay, run. There you go. Customers, ID, profile, blah, blah, blah. Okay. Now you saw it during this whole time, I used the reactive non-blocking HTTP client, and it wasn't that bad. I mean, this is fine, right? But one of the things I would like to do is to, if I have enough endpoints, I don't want to have to rewrite this client logic. So I might create a separate bean that is my CRM client kind of thing. And if I wanted to go a step further, there's a lot of options today in the Spring ecosystem to make that work even simpler. You can use Spring Cloud OpenFane, you can use Spring Cloud Square, Retrofit, and you can use Spring RetroSocket if you're using the RSocket protocol. But one thing that I like in Spring Boot 3 coming up is that we have new support, centralized support, consistent, consolidated support for building declarative interface-based clients. So I'm going to show you that. It doesn't exist in the 2.x builds, so obviously I have to create a new project here just for now. But this is another nice thing I can't wait to see in Spring Framework 6. So we'll go quick here as we're running short on time. Bean application runner. Okay. And I'm going to inject a pointer to an interface called CRM client at get exchange customers publisher of record customer integer ID string name customers. Okay, and that's just my interface there. It's a reactive stream of customers, and I'm going to use that here. So I'll say CRM client, and I'll say client dot customers dot subscribe. I'm going to print out the results. So, and that's it, right? I'm going to run that. Now I need to define the beans. Right now I need to do this. This is what it'll look like. Maybe a little bit more than this, but this is basically what it'll look like when the final thing comes. For now, you need to factory the individual beans required to support this, but still amortize it over all the different endpoints that you're going to consume as easily as this. You don't have to do it. You only have to do this once, even if you add 50 other methods to that interface. So I'm going to create a bean of type CRM client, and it in turn will require web client adapter, and this will in turn require a web client. I return web client adapter dot for client HTTP, and I need the bean here for the web client dot builder. And here I'm going to I'm going to set the base URL to be HTTP localhost 8080, and then I'll return this bean just like I did before. And I'll use that web client adapter. I'll say web client adapter, and I'll say return HTTP service proxy factory providing the adapter. And I'm going to create a client for crmclient.class. Okay, so there's my bean, and you could probably actually, I should probably do that. You can probably create this as a separate bean as well. So there we go, bean. Okay. And then this requires the web client adapter. Ready. I'm going to inject this into this finally, and I can just say that. So now whenever I want to create a new client, this stuff is done. I don't have to do it again for each new service. And I can then create as many interfaces as I want by just saying HTTP service proxy factory dot create client, passing in the name of the interface and so on. So let's go ahead and see what this buys us. Oh, this is going to fail because it's going to be on the port. Port is equal to 0. I don't care what port you're on. Okay, so there's the data. We have the netty issue, same thing, you know how to fix that. And now you make these requests, you get the data back easily, right? And you can do the same thing for RSocket as well. There's an RSocket version coming. So my friends, we've looked at a number of things. You know what just occurred to me? I forgot to mention that when we're looking at all the actuator stuff, there's actually a new unified approach to both metrics and distributed tracing coming in Spring Framework 6. It's called the observation API. So basically, you'll have a single way to describe tracing data and key value metrics data as well. That's another thing that's coming. But my friends, I hope you got something out of this. I hope you learned something new. A lot of this is already GA. You can use it today. Some stuff like the declarative HTTP clients that I just showed you is in the milestones for Spring Boot 3. I want to thank you for your time, and I'm happy to answer questions now and offline. But thank you very much for your time today, my friends. I appreciate it.
Thank you, Josh. Thank you, Josh. That was quite exciting as usual. Quite energetic, even despite of your voice, right? And you're cold, but
Thanks,
still man. Quite. You survived, right? You survived for the 1 hour session. So
well, hopefully other people survive too. Hopefully they got through it with me. Hopefully other people were able to get through it with me, even though my voice was terrible.
Yeah. No, I mean I'm pretty sure. So I don't see the questions, to be honest, Josh. I see Valerie is chatting that that was a super session. Thank you, Josh.
Thank you.
I mean, guys, if you have any questions, please chat Azer in chat channel. I mean, I know that we almost run out of time, but you still have the chance to ask probably one question. If not, then you know how to reach Josh in Twitter or through some other channel. So do not hesitate to reach out to Josh. Yeah, I mean, another comment that was a fantastic presentation as usual.
Thank you very much. I appreciate it, my friends.
Cool. Thank you, Josh, one more time for joining us today. Thanks for standing with Ukraine, and hope to see you next time in person, man.